Next we are going to see bitwise operators available in Python. So Python supports binary AND, binary OR, binary XOR, binary ones complement, left shift and binary right shift operators. So this binary AND performs AND operation. So this AND operation returns 1 if both the bits are equal to 1. If either of them is 0, it will return the value as 0. So the operator copies a bit to the result if it exists in both the operands. So AND equal to, the another usage is equal to AND equal to, in the sense the left hand side and the right hand side values are both are ANDed and the result is assigned to the left hand side variable. This is one more usage of AND operator. And binary OR. So this binary OR, if any one of the bit is set to 1, it will return the value as 1. It will copy a bit if it exists in either operand. So this OR equal to, this is the shorthand form. So the left hand side operator as well as the right hand side operand both are ORed together and the result is assigned to the left hand side variable itself. In the similar way, binary OR, it copies the bit if it is set in one operand but not in the both values. For example, if the bit of one operand is 0 and the same bit of next operand is 1, it will return the value as 1. So in another usage of XOR operation, C XOR equal to A, if it is given like this, then C is XORed with A and the result value is being stored in the variable C itself. And this tidal symbol is used to perform binary ones complement. So this is used to negate the values. That is, if 0 is in the bit, it is converted into 1 and 1 is converted to 0. And next is binary left shift. So this left operand's value is moved left by the number of bits specified by the right operand. So in the similar way, if this is given C left shift equal to B, if it is given, then the values available in C has been shifted according to the position, number of position given in B, and the resultant value is once again stored in C itself. And next, binary right shift. This is the binary right shift operator. The left operand's value is moved right by the number of bits specified by the right hand side operand. For example, C right shift equal to B. If it is given, the binary value of C has been right shifted to the number of positions specified in B and the resultant value is once again assigned in C itself. This is the program, example program for which illustrates the binary operation. For example, A equal to 60, the binary value of 16 is this, and B equal to 13 and the binary value of 13 is this. First, print, in the print statement, A equal to, the decimal value of A is printed followed by the binary value. So bin of A, this is a function which will print the value of A in binary format. And next, same way, B equal to, the decimal value of B is printed followed by the binary value of B is printed. So the output is shown here. A equal to 60, the binary value of A is shown, and B equal to 13 and the binary value 0B represents the binary value of the given number B. Next, C is assigned to the value 0 and C is equal to A and B, that is A and B both are ANDed together and the result is assigned to C and the resultant value is equal to 12. The binary value of 12 is this. So the result of AND is, we have to print C followed by the binary value of C. You can see here result of AND is 12 followed by the binary value of 12. Next, C equal to A OR with B, that is A, this will perform OR operation between A and B and store the result in C. The result is 61, the binary value of 61 is this. So print result of OR is C followed by the binary value of C. So you can see the binary value here. So the result of OR operation is 61 and the value is this. And C equal to A XOR B. So A XOR B, so the resultant value is 49. So result of XOR is equal to 49. So the value followed by the binary value of 49 is printed. Next, C equal to title of A. That is, A has been complemented and assigned to the value C. So now A value becomes A is 13. Then 1's complement of 13 is equal to minus 61. So the result of complement value C and the binary value of C is printed here. Result of complement is minus 61 and the binary value is printed here. Next is C equal to A should be right shifted with 2. Next, the resultant value is 240. The binary value is printed here. So the result of left shift is C with the binary value of C. C equal to A right shifted twice. So the resultant value is 15. So the result has been printed. So you can see result of right shift is C equal to binary of C. So the result of right shift 15 is being printed. Next, Python logical operators. So we have seen relational operators. Those relational operators used to find out the relationship, or it is used to compare the values of individual operands. If we want to find out or if we want to compare several expressions, we have to go for logical operators. So 3 operators available: and, logical, and, or, that is logical or, not operator which is logical not. So and operator, if both the operands are true, then the condition becomes true. If A and B is true, if A equal to true and B is also equal to true, this will return the value as true. Or operator, if any one value is true, if either A or B is true, then it will return the value as true. Not, if A is true, then it will return false. If A is false, it will return the value as true. This is used to negate the value. So this is the sample program and this is the output. Initially, X is assigned to the value true and Y is assigned to the value false. So print X and Y is X ANDed with Y. So true ANDed with false, obviously under AND operation we are getting false. So X and Y is false. This is the output line. Print X or Y is X or Y. If any one is true, the OR operation will return true. If both of them are false, it will return false. So in this case, X is true but Y is false, so it will return true. So X or Y is true. Print not X is not X. So X is true, so it will return the value as false. Next we are going to see Python membership operators. So these operators are used to test whether a variable or a value found in a sequence. The sequence can be any list, any set, any dictionary, any tuple or any sequence. So there are 2 operators available, in operator and not in operator. So in operator, this evaluates true if it finds a variable in a specified sequence. For example, if X is a member of sequence Y, then it returns true. Another one operator, not in, this will return the value true if the value is not a member of that particular sequence. So this is an example program for membership operator. Here A equal to 10, B equal to 20. A list is created with the elements 1, 2, 3, 4, 5. So if A in list, so the value of A 10, if it is available in the list, there is no element 10 available in the list, hence this will become false, hence this statement is ignored, it will come to the else part. So line 1, A is not available in the given list is printed. You can see the output here. Line 1, A is not available in the given list. Next, if B, that is 20, is not in the list, print line 2, B is not available in the list. So this is true. So B is not available in the 20 is not available in the given list. hence line 2 B is not available in the given list is being printed. So you can see the output here. Next, C equal to B divided by A. So B equal to 20 divided by 10, the value is equal to 2. If 2 in list, so you can find the second element here 2, then this will return true. So print line 3, A is available in the given list. So hence line 3 printed here, you can see in the output. Next, Python identify operators. So this is used to, identity operators are used to compare the memory locations of two objects. So is operator, is not operator. So if both the identity are equal, this is operator will return 1. If both the if identity of both the values is not equal, then this operator, is not operator, returns 1. So if id of x is equal to id of y, it will return 1. If id of x is not equal to id of y, it will return 1. So this id of x will return the identity of that element x. You can see an example here, a equal to 10 and b equal to 20. So print line 1 equal to a followed by the identity of a, and b equal to the value of b is printed followed by the identity of b is printed. You can see the statement, output statement here. Line 1 a equal to 20 followed by the identity, and b equal to 20, the identity of b is also shown here. If a is b, if the identity of a and b is same, this will print a and b have the same identity. Yes, if id of a is equal to id of b, then line 3 a and b have the same identity. So here also this will print a and b can have the same identity. So b equal to 30. Then print line 4, a value is printed, identity of a is printed, and identity of b is printed. The same way a equal to 20, here identity of a, b equal to 30, identity of b is printed. If a is not b, so a value is 20 and b is 30 now, so they are not having the same identity. So this statement is ignored and it will come here, print line 5, if a is not b, this is true. So the statement print line 5, a and b do not have the same identity. Next we are going to see Python operators precedence. So these are the operators and this is the precedence value. First exponentiation followed by complement, unary, plus and minus, followed by multiplication, division, modulo division and floor division. Next arithmetic operators plus and minus. Then right shift and left shift bitwise operators have the precedence. Next bitwise and bitwise XOR followed by bitwise regular OR. Next comparison operator, less than or equal to, greater than or equal to, less than, greater than, and equality operators followed by the assignment operators equal to, modulo equal to, division, floor division followed by minus, subtraction, addition, exponentiation, etc. followed by the identity operators is and is not, in and not in, followed by the logical operator not, or, and. So these are the precedence of operators. Thank you.